Welcome back again to the Ivory Tower Collections. In today's video, we're going to go over the process of installing a UAV board for improved composite and really good S-video output results inside of a Sears Video Arcade II console. This console is basically using the exact same case shell as what would eventually become the Atari 7800. But before that, Sears and also Atari released a console, a 2600 version of the console in that shell, known as the Video Arcade II, and in Japan it was known as the Atari 2800. So, let's get to it. What tools will we need for today's video? I would recommend some small needle nose pliers, probably some electrical tweezers of some sort. You're definitely going to need a number 2 Phillips. That's pretty much a staple that we always have to have. You're going to need a set of flush cutters, and you're going to need some good wire strippers. And then of course, in addition to these tools, you're also going to want to make sure that you have some various lengths of wire, and then obviously you're going to need some good quality solder, as well as a good temperature adjusting soldering iron. For cleanup, the toothbrush, but you're going to also want to have some good quality IPA on hand. I actually keep a good clean batch of alcohol in this little spray bottle, makes it easier for me to control where it goes. Also, you're going to want to have some Q-tips or cotton swabs on hand to help with your cleanup as well. Although I wouldn't say it's absolutely required, it would be helpful to make sure that you have a good multimeter as well that you can use. This is to verify your continuity with your wire connections, as well as just to verify points that you'll need to attach to with the wiring to make the UAV work. Let's take this thing apart. How do we go about that? Well, it's actually pretty easy. Very similar to the 7800, since it is largely the same case design, there are 5 screws that hold the console together. You got 3 along the front edge here, 1 on either corner, 1 that's offset, middle, and then you have 2 back here as well. So I'm going to go ahead and undo these right now. Now, all we have to do is just take the top cover off, and we can see the inside of the system. From here, we need to loosen the RF cable that's attached right here by the RF modulator box. And from there, the main board should just pretty much pull out of the console. Just like that. Let's talk a little bit about where we need to put stuff. Well, first of all of your wiring connections for the UAV board are going to be underneath the RF shield. So this will have to be removed in order to get to the points we need to. The other question is, where do we install the UAV board? Well, there's not a ton of room inside of this particular console, especially on the main board. If you don't plan to use the RF modulator, then sure, you could just remove the RF modulator off, and there's plenty of room here where you could then install the UAV board in its place. Another place where you can install it, and this is where I will be installing it in this video, is right up here in the upper left-hand corner of the main board, just below the color trimmer wheel. There's a nice little spot here between this row of some resistors and capacitors where you could put something in place, and the UAV board will fit pretty much just perfect right there. Before we do anything else and try to remove this RF shielding, be aware of the fact that there are these little tiny washers around each of the switches. It's not horribly critical if you were to lose these, but they do provide a better surface contact point. So yeah, you don't want to lose those. You want to keep those somewhere secure. At this point, it's now safe to go ahead and you can flip the board over if you need to. But let's go ahead and get the RF shielding loose. And like a lot of Atari systems, the RF shielding has little tabs around the edge of the top shield, which are twisted. So you'll just need to get a set of needle nose pliers, or I've got this little wire twisting tool here from the soldering kit that I've had for years. That comes in perfect. It's got a slotted end on one side that I can use to go over the tabs and straighten them up as needed. Like that. And then I should be able to lift the cover right off. And then to remove the bottom cover, you'll need to remove the two plastic sliders used for the color black and white switch and the channel selector. At this point, we've got ourselves a nice clear board that we can work from. The other place I was talking about where you could install the UAV board if you wanted to would be right here. It would also fit pretty well here. You got a nice flat spot here. But of course, if you do that, you wouldn't be using the RF shielding anymore. I tend to still use the RF shielding whenever possible. So in my particular case, I won't be installing it there. Again, I'll be installing it up here in the upper left-hand corner. I've zoomed in on the upper left-hand corner of the board a little bit because there's a few things I want to point out. What you're going to need in order to be able to connect up the UAV board, in addition to the different video points that will need to go onto the board, you're also going to need to give you a source of +5 and some ground. So you're going to need voltage and ground to apply to the board. Ground can be found in all kinds of places. Anywhere where you see empty exposed trace like this, usually like what's all the way around the RF shielding section, that's usually going to be ground. Most of the time on a lot of consoles, the outer trace or the outer plane that you can also see is usually ground, but not always. And that's the case with this unit as well, is that it turns out that this section of the trace that runs along the left-hand side of the board and along the back, that's actually part of the +5 volt rail that powers the left half of the system logic. So you want to be very careful that you don't try to attach that to ground. So as a result, here's where I'm going to source my ground and my positive voltage, my +5 from. Right here above this LED, there's an unused via located right here, and it's directly attached to this +5 rail. That's where I'm going to solder on my voltage wire to power on the UAV. And then for ground, I could solder onto this empty portion of the plane here from the RF shield. As it turns out, I will have to remove and modify some of the RF shielding to allow for my wiring to come through. But what I can also do, and what I'm going to do for purposes of this video, is this color trimmer wheel right here, this leg, the left-hand leg of the color trimmer, is tied directly to ground. So what I will end up doing in this video is I will just solder on my ground wire to the top of this. Makes it a really nice, easy reach. Let's talk about where to attach the different points for the UAV board in the main logic section here. So there are 5 connections that need to be made off of the UAV board that need to attach to various points on the main logic here. And all of those points is going to come off of this chip right here. This is the TIA chip. So I've got my meter here and I've got it in continuity mode. So pin 2 from this diode will attach to the via marked S right here. Pin 5, which is the top of this other diode, or the bottom of this resistor, will attach to the via marked as 2 on the UAV. Pin 7, I believe, is found at the top of this resistor here, and also the resistor directly above it. So either the top leg of this resistor or the bottom leg of this resistor can be used as your connection point directly off of pin 7. And that will connect to the via marked as 3 on the UAV. And then we need a connection from pin 8 directly over. That can actually be found on the next set of resistors directly afterwards. Same as before with pin 7, you can use either the top leg of this resistor or the bottom leg of this resistor to attach a wire from, and that will go into the via marked 1 on the UAV. Last is pin 9, right here. Now pin 9 is actually our color input signal. You can find that at the bottom of this resistor here, right next to the big green chiclet capacitor, which has this big trace that comes around and also attaches to the bottom of this banded ceramic capacitor right here. So either of those 2 points you could attach your wire to for your color input signal right here on the UAV. That just leaves audio. Now audio can be grabbed from a couple of places, but technically pins 12 and 13 are your audio lines, and they're actually tied to each other on the PCB. Here's pin 12, here's pin 13, and you'll see that they are indeed connected together. That's because there's a trace that's connecting 12 and 13 together. It comes off from right here, runs up like this, comes back over, hides in a couple of other different places. But ultimately, where I connect my audio from normally is off of this resistor right here. This is resistor R14. It's just above the two polystyrene capacitors that are also used for the audio filtering before it goes into the RF section. So yeah, that's where I'll end up grabbing my audio signal from. And that pretty much takes care of the connections that we're going to need to do. So from here, what I would recommend is to go ahead and wire up the wiring for the UAV side first, just because it might be more difficult if you have the UAV already attached somewhere to get your wires to it. So I would go ahead and solder on the wiring you need to the points that you need off the UAV, and then mount the UAV where it needs to go, and then route those wires, line them up, trim them, and attach them down to the points that we've notated here. So let's do that. At this point, I now have the initial wiring in place on my UAV board, and I've also got some Velcro applied to the bottom of it. And in the spot where I'm going to mount it to the board, I have another piece of Velcro here. I've already soldered in my 5-volt wire to provide the power I need for 5 volts. When it comes to the ground, once I've got the board in place, I'm just going to solder a small piece of wire from the ground pad off of the UAV to the left leg of this color trimmer. And then, and to show you how it all fits into place, I'll just show you right here. So I've got the UAV right here, and I am just going to snap it into place like such. Again, it fits in nicely in that little spot. So from here, I just need to make sure that all of my attachment wires, once they're routed where I need them to go, are going to reach where I need them to go. Again, I cut each of these up to roughly about 7 inches, but if you want to make sure you give yourself plenty of wiring, you can cut them to 8 inches. But again, that will depend on where you decide to mount the UAV board. To make things a little easier for myself, what I'm going to do is I'm going to go ahead and solder on my ground wire where it needs to go. Just like that. Then I'll put the UAV back into place. And then to solder on these wires for my power and ground, just going to get the rest of my wiring out of the way here, tuck it up underneath the board for a second, and just kind of measure out where I need my ground wire to go. Power and ground are in place. Now to go ahead and route the rest of the wires from the UAV board to their appropriate places that I specified earlier over here. Another thing that I would strongly consider as part of a UAV upgrade, really into any Atari 2600 or 7800 console, is to replace out the original voltage regulator. In this case, this is using a standard 7805 500 milliamp rated voltage regulator with one of a higher output. In this case, I've got a spare 7805 ACT, which is a 1 amp output capable voltage regulator. But this is just because with the UAV installed, the UAV plus the 2600 with certain cartridges that have more logic in them, like flash cartridges, things like that, it's right at 500 milliamp current draw that the default voltage regulator can provide. And because these things are, you know, old as they are, they're going to start to go out anyway, and it's really just putting a lot of stress on it. So I would highly advise replacing out the voltage regulator with at least a 1 amp output variant in the case of the 2600 with a UAV. So that's what I'm going to go ahead and do right now is I'm going to desolder this guy out of here and replace it out with a new one. There we go. New voltage regulator in place. I now have the initial wiring in place for the UAV board, and I'm ready to give this thing a test really quick. Before I drill any holes into the case, I'm of course going to want to test all this to make sure that it's working. So I have some temporary connections in place here. Here's an RCA attached for audio, and then I have an S-Video panel mount jack here that I can test. So I'm going to loop this thing around real quick and fire it up and see where we're at. I now have my camera pointed at my small little PVM display here, which has S-Video on it. And I've got the Sears Arcade Video II sitting here with the UAV. I've got some temporary connections on it just to test and make sure that the audio and the video output is working. So let's go ahead and power this thing on and see what we get. Now I have my Uno cart currently installed, and I know that that picture is going to be really washed out, so let me change the angle, and we're going to zoom in on it a little bit, okay? Because the reality is the colors are not correct. Now here's the test pattern for the color bar generator, and already it doesn't look quite right. And the main problem is that this is way too green, actually. It should be more of an olive, or almost like a, yeah, it should be more of an olive color, not this green. So let's take a look at the color purity test. Okay, well there's the green, looking very green. There's the red, which looks a little dark, almost brown. And then that's supposed to be blue, which does look blue in my camera viewfinder, but it is very purple to me on this actual screen. Let's go to the NTSC color bar test. Now, this is probably a really good example to show here that the colors are definitely not correct. So for starters, these main colors down here at the bottom, this should be green, this should be white, and this should actually be a really nice, pretty blue, and then this should be more of a lavender, but they're actually, this is a dark purple, this is more of a lighter purple, and then, yeah, these other shades are just completely wrong. Now the reason for this happens because, like a lot of 4-switch units, Atari added an extra resistor off of pins 6 and 9 off the TIA chip on the bottom of the board to improve the color saturation. However, this improved color saturation causes the colors to look wrong when output through S-Video or composite on the UAV. So let's take a look at that now. So to correct for the odd coloring that we saw just a bit ago, let me show you what the problem is. So let's get the board back out of here. Now, the component that's causing the odd colorization is an additional resistor, and in fact, some refurbishment kits from Console 5 even include this resistor to help with improved color saturation from the TIA chip. However, this resistor causes problems with the color output going into the UAV, and it just looks wrong. So, let me flip this over. But right here, there is a small resistor that has been factory soldered on and is attached to pins 6, and 9 of the TIA. Because here's pin 1, 2, 3, 4, 5, 6, 7, 8, and 9. But this is what we need to do. We need to remove this resistor off of the pins. Now you don't have to completely remove it. All you have to do is just desolder one leg of the resistor and then use something to kind of wrap over it. I'm going to use a small piece of some shrink tubing. So let me measure up some shrink tubing that I might need for this. About like that should be good. And then again, all I'm going to have to do here is just to remove one leg of this resistor. And I'll probably just remove it off of pin 9 here. There we go. Just lift it off just like that. Get this little piece of shrink tubing. I'll just kind of stick on there like that. And really the only reason for this is so that if for some reason you want to take the unit back to stock condition, or perhaps you like the odd coloring, then you can certainly put the resistor back into circuit. And it just keeps it there if someone should need it. But again, the shrink tubing is used to help prevent it from shorting against anything in the future. There we go. And so now what we can do is we can plug this back up again and check it out and see if the colors look better to what we expect. Let's take another look at this again. I've got my camera pointed here. Now I know the screen is really dark, but that's just so we can see the screen better. Let's go ahead and power it on with my Uno Cart. And immediately the menu looks correct as far as the colors go. This spot here looked way more purple previously before I disabled that resistor. And this green bar up here, the selection bar, which is now a nice little forest green type color, looked more almost teal previously. So let's go ahead and take a look at the color bar generator test. And right here on the title screen, these colors look a lot more accurate. We now have the more olive color that I would have expected on this screen versus the bright greens we were seeing before this. Let's take a look at the color purity as well. There's our green, there's our red, which now looks more red and not as brown as it did prior. There's the blue, which actually looks blue now and not as purple as it did before. And again, this is through S Video output, by the way. There's our gray bar, grayscale screen anyway. And then here we have the NTSC color screen. Now, the immediate differences here is that the lavender over here, or the light blue as it were, with the dark blue here, now looks more correct. Although the green is darker than it was previously. In fact, it might not even be showing up in the camera. But this is more accurate to what I would have expected to see. These colors all look correct. I would call this a success. I would say this UAV is working just fine in the Sears unit, and we have much better colors than we had before. And plus, I'm sure you can hear, but we also have audio working as well.